This is the fourth video on pointers. This video is different in that we're looking at pointers to arrays, pointers and arrays. This is the first time we're looking at pointers that access multi-valued variables. When we declare an array, we declare a area of memory that can hold multiple values. And we are accustomed to identifying each individual value by subscript. This is an example of implicit sizing where we are saying we want an array called vals, and we just list the values that we want to be in the array. So the size of the array is automatically 3. If we output the variable vals, which is the name of the array, you will see that it is displayed as a pointer. You were told many years ago that you cannot display the value of an array just by giving the name of the array, because we've discovered something important, that the name of the array is really a pointer. On the other hand, if we output not the name of the array, but if we dereference the array name or the array pointer, we get the first element of the array. So basically, if you dereference the array, you have access to the array element sub 0. Now, the array name and the pointer can be used interchangeably. So in this instance, we are declaring an integer pointer, val pointer, and we are initializing it to the name of the array. What's the name of the array? It corresponds to a pointer to the first element in the array. So that once we have established val pointer as a pointer to the array, we can now use val pointer as an alias for the array and provide it a subscript. Now, if we have a pointer called val pointer, then it is possible for us to do what's called address arithmetic. And if we take val pointer plus 1, it really means the next element in the array. So this is the same as saying increase the subscript by 1. Now the way this expression is written is critical, so pay attention. If I want to access the array using the pointer, I must dereference the address of the element that I want. If I want the second element for which I normally supply the subscript 1, I must form the address expression val pointer. What's val pointer? It's a pointer to the first element of the array. If I want the second one, I say the first one, skip over the first one, which gives me the second. If I want to go to the third element, it's the start of the array, move over 2. Notice that the parentheses are essential. So here's an example of what we just saw. With an array, we can access it using a subscript. If we have a pointer to the array, we can use the pointer and a subscript. If we have an array name, we can use the array name as a pointer and dereference it using address arithmetic, so that dereferencing the address vals plus 2 is equivalent to array name sub 2. And the same thing is possible through the subscript. So summary. Subscripting val sub I is equivalent to the pointer notation. Now again, pointers are just numbers, so in certain circumstances we can increment and decrement. And we just saw that incrementing and decrement for a pointer to array is tantamount to moving the subscript up and down. We can also add integers or add or subtract arbitrary integers from an address. One pointer can be subtracted from another pointer. Notice that the moment you subtract pointers, you no longer end up with a pointer. Instead, you end up with just a number. Okay. Notice that in this instance, we're going to output the result of subtracting two addresses. What is vals? Vals is the address of the first element in the array. Val pointer, here we set val pointer to actually the second element of the array, the third element. And so when we subtract this, we get the number of array elements in between these two addresses. If you want to allocate dynamic memory for an array, we specify the number of elements that we want when we do the new. So we're saying, I want to allocate space for doubles, but I want 25 such doubles. We can also delete a scalar by just saying here's the pointer. If we want to release dynamic memory for an array, we must put in the punctuation square braces to indicate that there are multiple values that we want to deallocate. We're going to stop right there.